So I'm graphing a tangent function, y equals tangent of x. What should we know about y equals tangent of x? Well, in the function y equals tangent of x, what's going to happen is that all of our asymptotes will be the same place as the secant was. That is, we know that since tangent of x is equal to sine of x over cosine of x, which I'm going to put over here, wherever the sine of x, wherever cosine of x is equal to 0, tangent of x will be undefined. Well, where did we say that occurs? We said that cosine of x is equal to 0 at x equals numbers like negative pi over 2, positive pi over 2, 3 pi over 2, and other odd multiples of pi over 2. All right, so for our intervals right here, when I mark off my graph, and I want to go from negative pi to 2 pi, so let's see. Here is pi over 2. Here's pi. Right. If we kept on going, this would be 3 pi over 2. This would be 2 pi. If we went to the back over here to negative pi, right, so we'd have negative pi over 2 here. Here's negative pi. This would be negative 3 pi over 2. This would be negative 2 pi. What will we say? Well, anywhere where these things occur, we say, well, tangent of x is undefined at these values. That is, these are the vertical asymptotes, so negative pi over 2. And positive pi over 2 are values that are among those numbers that we would make the function undefined. Well, what happens then in between? Well, now we would go through, and we could make up a little table right here and just kind of figure it out. But if you happen to know your sine or your tangent function values, it isn't very hard. What we're going to do is I'm going to start at negative pi over 2 this time, because I know that is the location of a vertical asymptote. And I'm going to end at positive pi over 2. Now, just like sine, cosine, secant, and cosecant, I have key points in between. Halfway through the period, I have 0. And I know what happens to tangent of 0. It's 0. But we need points in between our vertical asymptotes besides that to see what's going on. So let's choose halfway between 0 and pi over 2, which is pi over 4. I know that the tangent of pi over 4 is equal to positive 1. So pi over 4, I take my y value to be at positive 1, which I'll put here. And at negative pi over 4, which is halfway between 0 and negative pi over 2, my graph would be passing through negative 1. So if I come over here at negative pi over 4, my graph passes through negative 1, and my graph would come along the vertical asymptote at negative pi over 2, pass through the x-axis at 0, 0, come along through pi over 4, 1, and then head up towards positive infinity. Now, if I kept on going, what would have to happen is that this pattern would repeat, kind of like wallpaper. As I came along my vertical asymptote at 3 pi over 4, I'd have to pass through negative 1, then I'd have to go through 0, or pi 0 again. If I start on the left, I'd have negative pi 0, I'd be at negative 3 pi over 4, 1, and the graph would continue up towards its positive vertical asymptote over here. So this is the graph from negative pi to positive pi. The main piece of the graph that we're actually concerned about, the main period will indicate, is this one that goes from negative pi over 2 to positive pi over 2 and everything in between. So we'll take this piece of our graph to be our main tangent function, one cycle of our main tangent function right here. Here it is. All right, so what about cotangent? Well, a cotangent function functions in, well, sort of a similar way. For y equals cotangent of x, we're basing our function on the sine, right? Where sine is 0 to give us our undefined values, right? So we go back, cotangent of x we said is equal to cosine of x over sine of x. And you'll notice that I'm choosing the interval from 0 to 2 pi for this particular reason, because we know that sine of x is equal to 0 at values like x equals 0, x equals pi, and x equals 2 pi. And those are going to be vertical asymptotes of my function. So I'm going to go out here. I will choose, here's pi over 2. I'll make this pi right here. I'll make this 3 pi over 2 right here. I'll make this 2 pi. All right, so what can I tell about my function? Well, if the vertical asymptotes are at pi, and at 2 pi, and at 0, right? Don't forget the 0, right? That's always an important one for us right here. The cotangent function at pi over 4 is equal to positive 1. At pi over 2, we get 0. At 3 pi over 4, we would get negative 1. And the graph would come along our vertical asymptote, pass through these points, and go down our next vertical asymptote, and then repeat that same pattern over. And the reason why I wanted to show both of these graphs so that we could see those patterns between the vertical asymptotes, we would say, well, look, one major piece of the function's pattern occurred here on the interval from 0 this time to pi. And the main part of the function, at least one cycle of the graph, was right here on that interval from 0 to pi. So we think of that as the basic cycle of the cosine function, or the cotangent function, right? And so we might make a note right here that we're going to use when we're graphing this later on. The period, the basic period of the function, is equal to pi. And that's the same thing with tangent. The basic period of the function is equal to pi. So we'll use these facts when we're graphing our cotangent and tangent example functions in the next videos.